Hello, friends. If you remember, in 2014, there was a blockbuster film by director Christopher Nolan, Interstellar. In this film, space-related concepts such as wormholes, black holes, alien planets, were depicted in a scientifically accurate way. But perhaps the most shocking scene was at the end of the film. When in the climax, the main character of the film, Cooper, falls into a black hole. In the film, the name of the black hole was Gargantua. Cooper falls into the black hole with his spacecraft. Initially, everything was black all around him, complete darkness. But as he falls deeper, he notices some grain-like particles. These particles hit his spacecraft and cause scratches on it. There were some flashes of light, some sparks, and his spacecraft catches fire. He was forced to eject from his spacecraft, and he kept falling into the black hole. And suddenly, he found himself in a 5-dimensional space. A 5-dimensional tesseract. It was a mind-boggling experience. A place where he could communicate with his past self by using gravity. Seeing these scenes, you might have wondered if it is actually possible. Does this exist in a black hole? If we fall into a black hole, what will we see? Come, let's try to understand these aspects in today's video. Black holes remained largely unknown until the 20th century. A black hole is a region in space where the force of gravity is so strong not even light can escape. From the outside, you can't tell what is inside a black hole. Black holes haunt our universe. Dark centers of gravity that swallow everything in their path. Let's begin with the beginning of this story, friends. The history of black holes isn't very long. 100 years ago, no one knew about black holes. Because of Einstein's theory of relativity, black holes were later discovered. Friends, there are two parts to the theory: the special theory of relativity and the general theory of relativity. The special theory of relativity, published by Einstein in 1905, tells us how speed influences time. If you are in a spaceship that is going very fast, if the speed is too high, time will slow down for you. Relative to the people not on the spaceship, back on Earth. The word relative is very important because when you are in a spaceship, you wouldn't feel the time slowing down. You would think that time is flowing at the same speed as it normally does. But when you'll get back to the Earth, you'll find out that there was a difference in the flow of time. This is known as kinematic time dilation. And if you have seen my video on the time traveler, I have explained how this works in detail there. Not only speed, but even gravity can also result in time dilation, as shown by Einstein in his general theory of relativity. This was developed by him in 1915. The more gravitational force you'd experience, the more time would slow down for you. This is known as gravitational time dilation. And this was depicted amazingly in Interstellar. When Cooper and his team land on the Aqua planet, 1 hour on that planet equals 7 years on Earth. This happens on the planet because the planet was very close to the Gargantua black hole. So the gravitational force of the black hole impacted the time. To visualize this, Einstein wanted us to imagine a space-time fabric. Kind of like a mesh on which all planetary objects are placed. The space-time fabric bends due to the mass of the objects. And when the mesh bends, not only does it attract physical objects more, but it leads to time dilation as well, and the other forms of energy, such as sound, heat, or light, they are affected by gravitation as well. If there are such objects, it means that they'd be completely black. We won't be able to see them. because not even light can escape them. Friends, this is exactly what black holes are. But when Einstein presented his theory of general relativity, the concept of black holes was merely theoretical back then. Einstein knew that gravitation influences light. And theoretically, objects that can absorb light were possible. But Einstein did not know that there are actual black holes. In fact, when Einstein was alive, the concept of black holes seemed weird to him. He knew that there can be such things, theoretically, but then, theoretically, the existence of infinity is also possible. But realistically, practically, he did not believe that such things existed in reality. By the time he passed away, not even the term black holes was invented. An interesting fun fact here, a key point in Einstein's theory, was that light's speed limits gravity's influence. We don't feel gravity's force instantly, everywhere. Its upper limit is the speed of light. To use a practical example, suppose that the sun disappeared suddenly. As you know, we'll get to know this 8 minutes later, on Earth, about the disappearance, because it takes 8 minutes for sunlight to reach Earth. But according to Einstein, the gravitational impact of the sun's disappearance will also be felt 8 minutes later. Isn't it very interesting? After Einstein, the theory of general relativity was worked on by many scientists. Like there were several equations, they solved those equations and tries to derive the solutions, and by getting to the solution of these equations, it was theoretically proven that things like black holes do indeed exist. By the 1960s, researchers and scientists had finally agreed that not only theoretically, perhaps one day realistically, we'd be able to see black holes. Because these do exist in space. The term black hole was used for the first time by a magazine in 1964. But only after 1967 did, even though the term black hole sounds quite sensational, it is a misleading name. Black hole. It might sound like there's an actual hole there. But that's not the case. There's no hole in the space. Black holes are formed by stars. So there's some material at its center. But in the stars, even our sun is a star, there's a continuous nuclear fusion reaction at their center. These reactions produce heat and light. The heat being produced sends a force outwards, and at the center of the star, there's the force of gravity. This helps the star remain intact and alive. This is how the stars maintain equilibrium throughout their lives. The forces pushing outwards due to the reaction, and the forces pulling inwards due to gravity. But these reactions take place when a fuel exists. Either hydrogen or helium. The fuel wouldn't always be there. It would get burned up at some point. And when the fuel ends, there wouldn't be any forces pushing outwards. And the gravitational force pulling inwards wouldn't be countered by an equal force, so that star will collapse on itself because of its own gravity. This will take a long time, by the way. Our sun's life expectancy is around 10 billion years. But what happens next depends on the mass of the star. Let's look at the chart of the life cycle of a star. If the mass of the star isn't high, that is, if it was a small or average-sized star, it turns into a red giant. After which it can become a planetary nebula, or a white dwarf. But if it was a huge star, a star with a lot of mass, when it runs out of fuel, it cools down and turns into a red supergiant. And then the supergiant bursts and turns into a supernova. After this, a tiny core remains. If the core is tiny, it is called a neutron star, but anything bigger than that, we call it a black hole. Basically speaking, the mass of the star, after it collapses due to its gravitational force, becomes small and condensed. It can turn into a black hole. Specifically, how small is the volume of the compressed star? For a star as big as our Sun, if that turns into a black hole, the diameter of that black hole will be merely 50 km. Can you imagine the volume getting this small? But the interesting thing here is that our Sun will not grow up to be a black hole. This was proven by an Indian-American astrophysicist, Subramanian Chandrasekhar. He developed the Chandrasekhar limit value. He said that the maximum mass of a white dwarf can be 1.4 times the mass of our Sun, above which it cannot be stable and would turn into either a neutron star or a black hole. But since our Sun, the Sun, is under this limit, now let's understand how black holes are. There are mainly 3 to 4 types of black holes, friends. The first is the stellar black hole. That is the most common type of black hole. The black holes that were created by stars. Scientists estimate that in our Milky Way galaxy, there are anywhere between 10 million to 1 billion such black holes. Then, there are the primordial black holes. These black holes are as small as an atom, but their mass is like that of a mountain. It is an assumption that they are as small as an atom. Friends, these black holes are merely theoretical, hypothetical. We do not know much about these. The third type of black hole is the supermassive black hole. These black holes are enormous, so big that their mass is more than that of 1 million suns combined. And it fits into a ball whose diameter is as big as that of our solar system. Scientists believe that at the center of every major galaxy, there is a supermassive black hole. The supermassive black hole at the center of our Milky Way galaxy is called Sagittarius A equals SSSs, and the black hole in the film Interstellar that was named Gargantua was said to be a supermassive black hole. Additionally, scientists believe that there may be a fourth type of black hole too. Though it cannot be said for sure, the fourth type of black hole will be intermediate black hole that lies somewhere between the sizes of stellar and supermassive black holes, although no proof of it has been discovered yet. One thing that you have seen in the film Interstellar, and the photos that you have seen till now, and your interpretation of them, the black hole isn't like a big black ball that sucks everything around it. The black holes look somewhat like this. This is the black hole as shown in the movie, because it is in HD and more three-dimensional than the photo captured by us some time ago. The first thing that you'd notice in this photo is the orange-colored ring that forms around the black hole. It is known as the accretion disk. It is an important feature of black holes. As you know, the gravitational pulls in black holes is very high, so due to the gravitational pull, a lot of gaseous matter and debris is attracted towards the black hole and remains floating all around it. Similar to how the planets revolve around the Sun because of the Sun's gravitational force. The difference is that the gravitational pull of black holes is so strong that the things revolving around it revolves at a very high speed and get so heated up that they turn into a flowing fluid-like matter. They literally become fire-like particles that are hotter than 1,000,000 degrees Celsius. The closer they get to the black hole, the faster they revolve around it. The particles revolve so fast that they get rubbed together and compressed. This causes them to start glowing. They emit electromagnetic radiation, which are mainly X-rays. This accretion disk was depicted very accurately in the movie. The only thing they got wrong was that it isn't actually orange. Human eyes cannot see X-rays. X-rays lay outside the spectrum of visible light. We simply represent it in an orange-yellowish color so that we can represent it. The real color of this disk would be closer to blue. In 2019, the first photo of a black hole was taken. Even in this, the yellowish-orange color was used to represent this accretion disk. One thing that you can clearly notice in the actual photo that you might not notice in the movie is that the particles on one side are brighter than the other side. There's a simple reason for that. The particles spinning towards us seem brighter to us, and that are spinning away from us seem dimmer. This is due to the Doppler beaming effect. What is light made of? Photons. The photons start orbiting the black hole. This means that if you reach this area of a black hole alive, it is theoretically possible to see the back of your head, since the light is traveling in a circle, in the formation of a ring. After this point is the boundary of the black hole. This is known as the event horizon. It is considered a boundary because after this point, the gravity is so strong that even the light cannot escape. Everything is black beyond this point. If you are falling into a black hole, and you have crossed the event horizon, theoretically, there's no chance of you escaping. If not even light can escape it, how would a human? In the film Interstellar, it is shown that Cooper's spacecraft continues falling into a black hole, cross this event horizon, and then suddenly he reaches a five-dimensional space. This part of the movie is purely an imagination. It is speculation because we do not know what is inside the event horizon. In this theory, the center of the black hole is termed singularity. Singularity is the region of a black hole, the center where the curvature of space-time is infinite. Do you recall the mesh that I talked about in the first half of the video? The heavier the object, the more the mesh of space-time will bend. In the case of a black hole, this is bent so much that it stretches infinitely. As we know from the theory of relativity, time, energy, and everything else is affected by gravity. With the increase in the gravitational force, time keeps getting slower infinitely. But what does it mean for time to get slower infinitely? Does this mean that if you go inside a black hole, and if you ever could get out of it, the universe outside would have ended for the rest of us? We do not know. We can only make theories. What do you think? Comment below and let me know. There are some interesting theories that are suggested. Like we cannot see inside a black hole from the outside, because the light is absorbed into it. One theory says that inside the event horizon, light reflects off of at multiple points before reaching singularity. So it is possible that inside the event horizon, things would actually be visible. The things that we have seen for sure about black holes is this single photo. This photo taken by the Event Horizon Telescope on 10th April, 2019. This proved the existence of black hole practically. About 100 years after they were proven theoretically. One thing is sure here, if you fall into a black hole, the chances are that you will disintegrate into pieces due to the gravitational force. You will die in milliseconds. But even so, friends, there is no need to be scared of black holes. Earlier, many people had this misconception that the black holes suck up all matter, keep getting bigger, and eventually it will end the whole universe. But that's not how it works. As I told you, at the center of each galaxy is a supermassive black hole. And all other planetary bodies and stars in the range of the black hole revolve around it. In the same way that all planets in our solar system revolve around the sun. The same thing happens at the center of the galaxy. albeit in a much more powerful manner. As a conclusion, if you maintain a proper distance from a black hole, if you maintain social distancing, you will. That's all for now. If you liked this video, you can watch more space-related videos. Do watch the one on time travel, if you haven't already. These concepts are explained in detail there. Thank you very much.